In semiconductor packaging, warpage determines whether products ship or don't. At every level of assembly, bonds form only when warpage stays within tolerance. When it doesn't, there is no electrical connection. The tolerance is measured in microns. The problem is becoming impossible to ignore. AI systems demand larger packages, more dies, denser routing, and increasingly complex structures. As complexity grows, so does warpage. Some of the industry's most advanced products have already been redesigned, not because compute was impossible, because warpage couldn't be predicted early enough. This isn't a problem the industry ignored. It's a problem the industry learned to live with. Physical experiments are accurate, but each design iteration can take months. Calibrated models work until the design changes. Simplified simulations produce results, but only after discarding the geometry that determines real warpage. Different approaches, the same compromise, because no practical alternative existed. For decades, engineers adapted their workflows to the limits of computation. What you're seeing changes that. This isn't simply faster simulation. It's the first time manufacturing resolution warpage analysis becomes computationally practical. The native design, every layer, every metal line, every via before engineering decisions are committed. 3-micron resolution, 225 degrees Celsius bonding temperature. Run. 392 microns. But the magnitude isn't the breakthrough. The shape is. The warpage follows the actual layout, the metal distribution, the residual stress, the real geometry. Simplified models can approximate the answer. They cannot reproduce this. And this is the information engineers need before products are built. 1.2 billion degrees of freedom. Manufacturing resolution, native design, under 4 minutes. Not an approximation, not a surrogate, a fundamentally new engineering capability. For decades, manufacturing resolution physics was something engineers validated after design decisions had already been made. Today, it becomes something they can reason with while the design is still evolving. Continuous physics reasoning.